Hi, my name is Adam, and today I'm going to briefly explain some details about my thesis. The title of my thesis is Combined Control of Steering, Wheel Torque, and Suspension for Emergency Lane Change. Note that the vehicle that I'm using in my thesis is capable of independently providing torques to each wheel, and both the front wheels are steered together. Imagine you're driving down the road and suddenly an obstacle appears in your way, and the only option is to conduct an emergency lane change. Given our vehicle capabilities, providing the torque inputs to every wheel while steering the vehicle is an impossible task for a human. In contrast, a computer with a decent processing power can do it easily and precisely. The first step to execute the emergency lane change is to generate a trajectory to follow. Then the trajectory data and the vehicle current state data is fed to a controller. The controller computes the forward, sideways, and spinning forces of the vehicle to an optimization algorithm, known as the optimal tire force distributor. The algorithm computes forces needed by the wheels to achieve the general trajectory, while another controller will take the data and give commands to the steering and torques to the wheels. Meanwhile, another controller will obtain the shaking and tilting motion of the vehicle and control the suspension to reduce the shaking and tilting motion. Now I'm going to explain how the optimal tire force distributor contributes to the research. Note that the example given is based on a specific time step. Pay attention to the figure on the right. There are 4 centers for the circles, which represents the 4 tires of the vehicle. The top 2 circles represent the front tires while the bottom 2 circles represent the rear tires. The red dashed line circle represents the maximum tire forces that each tire can have at a specific time step. The blue and green circle represents the direction and magnitude of the tire forces generated by the ordinary and our proposed method respectively. The larger the radius of the circle, the bigger the magnitude. As you can see, the blue circle overlaps with the red dashed line circle on top of the left side of the figure, while the green circle does not. This meant that the front left tire cannot generate additional tire forces. This is a problem since the vehicle may still require additional tire forces on the front left tire to execute future steps for the emergency lane change. Even though the magnitude of the tire forces for the rear tires generated by the ordinary method is lower than the proposed method, if the magnitude of the tire force exceeds the red dashed line circle, then the vehicle will become unstable. Therefore, the proposed method is better than the ordinary method. Thank you for listening to my presentation.